Right, coming up, we got an interesting panel. We're gonna have a great talk. Yeah, make it even. So we have Greg Flay, an old friend, great guy, VP of Technology and Data at Austin Energy. Thank you, Greg, for being here. We have Byron Rojas, CEO of Easymetering. Thank you for being here, Byron. Byron actually was received the Entrepreneur of the Year award last year, and Easymetering is a founding CEDAR member. Rick Maldonado, VP of Grid Modernization at CPS Energy. Thank you for being here, Rick. And then Dr. Semih Aslan, my partner in crime, Associate Professor of Electrical Engineering, and the chair of the program, even though we call it here program coordinator. He is a badass dude. We're gonna have a lot of fun with this lab. So anyway, so what I want to do is get us rolling. There are some questions that we had rehearsed. We talk, I call them up, they call me back amazingly, and we hang out and talk a little bit about things. But before we do that, I want them on their own words to tell you and tell the audience who is watching, because we're broadcasting live. What do they do at the company? What's going on? Anything that is going interesting in the company? Some of the projects they're working on, perhaps anything that is keeping them up at night, any plans or anything like that. So take a couple of 2 or 3 minutes. We have an hour, so feel free to share as much as you like. Let's start with Rick.
Good morning, everyone. So my name is Rick Maldonado. I am the VP of Transmission, Distribution Engineering, and Grid Modernization at CPS Energy. Certainly a pleasure to be here today. Thank you for the invite. My responsibilities are not only the maintenance of the T&D grid, but also we build the substations, we design substations, we have all the engineering functions for the wire side of the house and the construction part for that. We do have a small innovation team, which is dedicated to really look at the things that y'all are looking at here, is all of the disruptive technologies that are out there, particularly in the sensor space, so that we can gain more awareness of grid activity, in particular with the distribution system, where we see the most disruption happening in the coming years.
Thank you. Thank you. Semih?
Hi, my name is Semih Aslan. I'm associate professor. Sorry. And so I'm a program coordinator, and I hope that some of you will visit Texas State Ingram School of Engineering labs, and then we'll show you some of the work we do in real time. Mainly, my research is heavily for hardware optimization, and also we work in machine learning and deep learning and AI technologies to help implement into some of the real-time problems that we face. I'm also IEEE Central Texas Section Secretary, and as well as Communication Society Secretary. So I actively involved with the ComSoc, especially how we can implement 5G, 6G into smart grid systems. So,
thank you, Greg.
Thanks for the invite, Andres. So Greg Flay, VP of Technology and Data, oversee the traditional IT function within Austin Energy, as well as the strategic planning function for the organization. We also have a data analytics function as well that is kind of undergoing a rebirth currently at Austin Energy, trying to more expeditiously meet the data analytics requirements of the utility. So thanks.
All right. Byron?
My name is Byron Rojas. I am the founder of Easymetering company. We are in the AMI space. My company is an AMI vendor. Our company is developing technologies, based on cellular technologies for meters and grid devices, and including a smart appliance too. And now we are here innovating in the concept of the smart meter, because I think that the smart meter is the essential and unique device used to sell and buy energy is very important in the smart energy economy. I thank you for inviting me, Andres. Thank you so much.
Absolutely, absolutely. So if I go to my questions, and again, they had time to think about this, so I'm gonna kind of come back to them and take my glasses here. So maybe, you all can take a shot at some of the first questions, and then eventually we'll open it up. But what's currently going on in terms of new technologies, or what are the things that you're exploring that are interesting or have a potential great benefit for the journey of managing the grid better as we move from a centralized to a decentralized? So what are some of those key technologies or key things that you're looking at, maybe more now than ever before? Rick?
So there's a lot that we're looking at. So it's hard to boil it down to just a few points. But for the context of this group here, so I mentioned sensors and smart devices. We're really deploying an army of electronic reclosers out on our grid to solve the resiliency issue. Customer expectations continue to increase. Electronic reclosers and all of the back office support systems with our ADMS that is really going to optimize how we have that flexibility on the distribution grid. I think one of the unique things that we're doing that as Andres mentioned earlier, that we are looking at our system from a more integrated approach. So typically we had our transmission system, which operated over here, our distribution system over here, and of course generation was in their own shop. But as we get to an environment where we're going to have the bidirectional grid and we're going to have distributed energy resources, now we're going to have generation resources on the distribution side, which is going to add a tremendous amount of complexity to how we operate that distribution system. So back at our control centers, we are undertaking an effort to integrate our transmission system and distribution system, SCADA systems. So our EMS and ADMS are migrating to be on a single platform. So that way that the interoperability and that data exchange can happen in a lot less time, with reducing the impacts of data latency, because we're just going to have that kind of communication to operate the distribution in the future.
Great, thanks for sharing. I'm going to skip you for a moment, and I'm going to go to Greg, the two utilities. Greg?
Sure. We have quite a few things we're working on right now. One of the areas that we're looking at is reliability as a service, and what is required to do from a system standpoint, in some cases policy standpoint, financial standpoint, to basically make that a reality and kind of produce a win-win-win for our customers. In terms of greater reliability, obviously greater resilience in terms of their own energy needs, but also support for the grid more generally, as well as a economic benefit. There's an economic factor, financial factor, obviously, in there as well. So getting all that up and running and going is a bit of a challenge on quite a few fronts. We've also begun to use our AMI, very rich AMI data that we've got, which is a blessing and a curse for everybody, and identify folks who may not, for example, be enrolled in our EV charging programs, but who through their signatures, their profiles, we can detect probably have EVs. So we identify for the customer programs that can help the customer that the customer isn't even aware of. So those are a couple of the things that we're working on right now. Thanks.
Thank you. Thank you. Byron, what are you seeing perhaps from some of the customers that you're helping? What are they working on? What are their priorities? What are their focus? And then what are you trying to do? What technology, what new things are you trying to do I don't know if you're going to announce Easy Lab at some point.
Okay. Yeah. Before to answer your question, I would like to say that my company is focused in different trends now that the utilities and the smart energy transition is going on. We are focused to deploy private networks because I think that is very important. The bandwidth that in the future of the grid, because it's necessary to control all elements in the grid, not only in the grid but also behind the meter. It is very important to have a new vision of the networks. Yeah, and another trend is edge computing, and Easymetering is working on edge computing. We create a smart network interface in the meters, and we are providing more capabilities in the meter through our technology. And this is very important because now we are working with customers in the way to provide benefit for utilities, but also for customers too. Yeah, for example, our technology is the meters. We enable the meters in order to communicate with cellular, with Wi-Fi, with Bluetooth, and we can to connect with different appliances. For example, the idea behind all this is that we want to provide a new way in order to do more smart energy. This is one thing that we are working in the technology, in edge computing technology, okay? And another thing that we are working now, the Easy Lab, is a very good project. I think that is utilities, and I think that need explore new technologies, new infrastructure technologies. And we are working now at Cedar here with Texas State University, with Andres. We are providing an education product. It is an Easy Lab. It is a private LTE and a smart grid solution in a box. And we want to explore new development in order to provide more benefits, not only utilities, but also customers. Yeah, this is that we are working.
And I think the Easy Lab is out there, right?
Yeah, Easy Lab is in our stand.
In our stand, and you're also going to be able to see it on Friday if you're going to do the tour. But if you're not going to be here on Friday, then I encourage you to stop at their stand right around the corner here to see the box, and you can actually get one of those boxes and bring the lab to you. So, Professor, what do you think of all this, and how are we adding value?
Oh, it's exciting actually, because I used to work in a large transmission company in Turkey in 1994 and 5. Back then, and compared to right now, the way that we access the companies are way different. So it is exciting that as Texas State Electrical Engineering, so we have a couple of approach. One is education. So we are adding new courses in the power systems. So hopefully we will get a power related concentration. And also we applied for a PhD program that has power concentration in it. So hopefully we will be adding more smart system capability in research and as well as workforce. In terms of research, we are working on heavily, we are talking a lot, sensors. So we are developing sensors as well as we are doing data collection, data cleaning, and data analysis based research, especially applying some machine learning and AI type of algorithms to make a proper decision. And that is not just related with power. Obviously, we are also working with, especially myself, underground sensor network for water and leak detections, for example. I mean, we are actually working on applying the machine learning into those systems. And then the last thing is, doesn't matter how much you make things smarter. We are also trying to educate with outreach program, the high school and elementary school kids in terms of power and energy, how they can actually go to the next level, not just the users, also try to be part of the problem to eliminate this problem in the future. So.
Right. So let's switch gears real quick because they're working on a lot of things, but now I'm curious. So why are we working on this thing? What are the challenges, Rick? Is it renewable energy? Is it DER? Is it the EVs? Is it all of the above? What's the most important challenge you're trying to solve? So we're curious.
Well, so I think there's multiple challenges that are forcing us to go down this path. So we have decarbonization, which is really reshaping how we manage the grid. Obviously, when the traditional grid was a lot easier to manage than what the grid's going to look like, but with the loss of inertia systems and with more inverter-based resources being deployed. We also have the fact that electrification is on our doorstep. Fortunately, it's been tempered somewhat, but we're waiting for the Amazons to really electrify their fleets and other providers. That's going to be significant just in transportation alone. And there's other electrification efforts that are going to happen that we're going to have to deal with. And the severe storms are becoming a lot more frequent, and our customers are expecting a higher level of service. So really improving that resiliency is a key driver. And I think the last thing that is kind of putting us in this space is the emergence of the prosumer. So consumers are going to want to have their services considerably different than the traditional model. In some cases, they may want to participate in some sort of aggregator through, like what was mentioned earlier, through those aggregation services. So those are the elements that are forcing us down that road.
Got it. I'm reminded here that I should promote my book here for the audience. You should read this. But Greg, similarly, but maybe a little differently, right? I mean, part of the challenge, and CPS has the same challenge, maybe Rick can chime in later, but you both are, perceived by everybody to being an urban utility only, a downtown. But you guys service a bunch of other little cities, both of you, and the service territory is kind of gigantic for both of you. But so tell us a little bit about, you talked about resiliency as a service. What's driving? What's the top thing? What's driving? What's microgrids, renewable EVs, all of the above?
Yeah, I think for I don't know how many folks here Central Texans. Yeah. So February was interesting with what we call Winter Storm Mara. Other people just call it ice storm. But that really was challenging, especially in these smaller communities outside of the central urban area, with the number of trees that were affected, the number of damaged power lines. Getting in and restoring energy in those situations was extremely challenging. It was one resident said, "I've lived in Austin 65 years. I've never seen anything like this." Right. And then Uri was only a couple of years back. So being able to handle these kinds of events better is kind of one big looming challenge, I think. The other challenge, again, for Central Texans, or actually Texans in general, the last few weeks, sunset has been a nightmare. For those tracking the kind of available energy on the ERCOT grid versus the demand, once the sun goes down, it has really been a significant problem in Texas. We've come very, very close to going into rotating outages. So I think that the distributed energy resources, the solar, and so it's already here, right? And clearly, as a sector, we've lagged in responding to that. So with all these intermittent resources, storage obviously has to be a piece of the solution, but that's a challenge without things burning up. So I think that these are really pretty serious challenges, and I don't know if we have those answers in place. Even something as basic as a DERMS, right? having a DERMS that does the physical side and the financial side at the same time, we're still trying to figure that out. So a lot of challenges, technology.
Yeah, interesting. How about you, Byron? Any challenges that you see from your customers in other countries here, or any challenges that you are working on to solve?
Yeah, I think that the smart grid and smart energy and utilities, they are the right driver in order to digitalize the energy. And I think that a big challenge is do faster the adoption of new technologies. It is a very big challenge. It's very important because I think that the transformation of the grid is very important with new technologies. And this is a challenge, and the opportunity, I think, that for utilities is in this case is education. I think that I would like to invite utilities to open mind because it's needed it's very important, education in the new trends of technologies. Yeah, we can find more innovation, we can find more business model behind of all opening. Yeah.
Got it. Semih,
yeah.
any thoughts on the challenges of perhaps some of the things that we may be thinking, short term, near term, after the lab opens? Anything you want to talk about the lab?
Yes. Obviously, one of the things that we are hopeful with the lab is one of the biggest problem is we're talking about the California is called like a duck curve, to how we can actually store the one that we are producing. I mean, now I think it's getting better and better, the production, especially during the noon times and when we have the renewable energy possibilities, especially with the solar. So with the lab that we will have a really good research opportunity for new innovations in battery and storage. I think that's going to be one of the biggest challenge and biggest opportunity as well. And then as well as creating some type of security. I mean, I think that's going to be another challenge that we are hoping that going from 4G, 5G, now going to 6G will answer some of those problems that we are going to face in the future. So,
okay. That's great. So, be molding some questions because I want to really have a good exchange here. If you had to pick sort of a new change on policy, anything that would help the business of building a smart grid be easier or more lucrative, or however you want to think about it. But is there anything missing in the policy and the rules of the utility and how it works today? Carbon tracking, carbon markets. Is there anything missing that would make the job easier, Rick?
So that's a tough one. I tend to shy away from policy type questions, but I will say that so integrators move at a very rapid pace. We've had a record number of solar and battery integrations into our transmission system, moving really, really rapidly, which in a lot of cases has required us to build transmission type facilities. In light of that, I'm going to say that perhaps easing the process of acquiring right away and getting permission to build transmission facilities or interconnection facilities faster may be the thing that I can think of off the cuff.
That's a good one. Greg, anything?
No, I think just generally the policy frameworks that we do have gotten us to a position that we have currently in Texas where the dispatchable generation just is not adequate to meet the needs, and it's not a single policy decision, but it's been over the course of time. This is where we're at today, but I think the only remedies would have to come from the policy area.
Yeah, it seems to me, and I asked the question because I was looking at these guys the other day, and I don't know if you've been, I know you're paying attention, but I remember vividly 6 years ago, our peak was around 75 gigawatts. And the peak now is roughly 86 gigawatts. So 10 gigawatts of growth in 6 years. We're kind of growing too fast. Do you feel that? I mean, like, are we off the charts on truck rolls and adding connections? And what do you think, Rick? Is San Antonio going through the roof?
Yes. So, we've had a steady growth rate for years, which hasn't really been the surprise there, but the emergence of data centers and large industrial loads has really grown very rapidly. So
What about crypto?
fortunately, we haven't had to deal a whole lot with that in San Antonio. But predominantly data centers, which have a very short time frame to get up and running, have they're exploding all over the country, but we've really felt that presence in San Antonio.
Yeah. What about you, Greg? What do you think? Growing
Yeah.
too fast?
Yeah, I think probably from our perspective, most definitely, with the, relocation of tech company headquarters into the Austin area and the attendant increase in just overall population. Yeah, it's pretty difficult to match that.
Yeah, as they say, people don't move here when they move here. And we heard from Hope, right? 1,200 people a month moving to Texas. Oh no, I'm sorry. Every day, right? Is it every day? Yeah, every day. And I think the number in San Antonio and Austin are roughly similar, 100 plus, every day. And they don't bring water and power with them. So they do bring their car, which creates traffic. I think that was Adler actually who said that yesterday. But I'm curious about a few things. And so, Byron, help us understand what is the vision of an energy future? I'm a consumer. What am I going to get from having your smart meter in partnership with CPS and Austin Energy? And what does that look like? Am I getting alarms? Is the phone ringing all the time? Am I trading with other people? What's going on in that vision?
Yeah. First, I would like to say that the penetration of smart meters technology is very low compared with the time that is developed this technology. More than 20 years of smart meters. In United States, only 69% are smart. And in the rest of the world, is the penetration of a smart meter is very, very low. I mean that it is very important to have a smart meter technology in order to digitalize the energy business. It is the most important thing first. After my vision, I think that create new business model, in order to sell energy behind the meter, new opportunities to create new service of energy for different energy vendors, clean energy vendors, for example, in order to sell for a specific appliance, for example. Now, in Chile, we have an experience. We are working in Chile in a project. The regulator, the government, they incentive the use in heating systems, electrical appliance for heating systems with very low, cheaper, very low rate for energy. It is very interesting because they are trying to incentive the use of clean energy. It is another. I think that in the future we need to create new business model in order to sell energy. Yeah, you imagine, for example, you go to Walmart or different store and buy appliance, including new package of energy. This could be very interesting for the future in order to create a new market in order to incentivize the clean energy. I think that this is my vision. I think that the meter is very important and is very essential in the energy economy. And now they are using only for reading automation, But I think that we need to reinvent the role of the meter in the grid and in the energy industry. Yeah.
Yeah, interesting. Semih, any thoughts on how the R&D can help accelerate these things?
Yes, I mean, as we were talking about, right now everything is about how the power, distribution, and also we have a lot of work in end users. So how can we actually reduce the need for power, like developing LED light systems, for example, from that to low power components, and also heavily work on like electric vehicles, EVX or EVG kind of things, that how we can actually use those type of systems to actually store the energy in the cars and later on use it at nighttime, for example. And yeah, we are actually trying to address it in a little bit differently, but still is I think the problem is not just one-sided. It is like a whole from a production all the way down to end user that we need to address those. So
absolutely. So we have to talk about AI, obviously, because it's the talk of the town, right? And how many of you are using ChatGPT right now? Anybody? Yeah, it's saving a lot of people's lives, right? And you can sleep in another hour and then go to ChatGPT and get your paper done or whatever. It's really interesting. In fact, I find it interesting, digress for a moment here, that the hottest new job that the universities are trying to figure out, we're discussing this, is being a prompt engineer. It's a new degree. People are gonna get a BS in prompt engineering and maybe a PhD in prompt engineering. And you can, I mean, think about it. I mean, the hope from USPTO said, look, there are patents being filed by AI bots, right? I mean, like, this is fascinating. So I want to file 52 patents, one every month, on the following subjects, get them ready for me and write them up, and I'll put the money in the bank and da. And so I want to be on that list of 10,000 patents a day or something, see what happens, But anyway, I digress from that for a moment, a little levity. Tell us, for Rick and Greg first, so AI and machine learning analytics, you've been using it forever. It's a journey, it's getting more and more. Can you share a little bit about where are you using it today? Some examples, or what systems, what services?
So sure. So data analytics is something that we feel that we're going to continue to get better at. That's just something that is invaluable in making quality decisions for us. One of the new things that we're using it for is so we're trying to so let me back up a little bit. One of the things that we're preparing for is that distributed energy resources out on the grid. In order to do that, we're going to have to host batteries or solar on the distribution system, which was never intended to be bidirectional the way we built it. So we're leveraging the meters, AMI meters, all of the different data sources to try to get better awareness of what the grid is really looking like, and trying to get that in real time so that we can not only host these services, but that, while those services are online, should we have an event, an outage or something, that we better know how to respond with those services, either they become available or unavailable, to help us improve our resiliency.
Got it. Greg?
Yeah, so interesting topic. I am the chair of the Large Public Power Council CIO Working Group, and we had this as a conversation topic actually just yesterday, about kind of where, at least from the LPPC members of municipally owned utilities, kind of where are we at? And the answer is not very far, not surprisingly. There are a number of people, probably 85% of that group was looking at it. One had a proof of concept underway. There's enormous, fear around AI. There's also opportunity around leveraging it, for example, for customer service. But as you know, we're continually warned you can't use AI without adult supervision. So, you know, sending the wrong information from some large language model that we give to a customer that makes a bad thing happen could be really a problem. So I think, like, at least with the rest of the L2PC, we're still kind of looking at it, but haven't engaged in a proof concept pilot yet.
Got it. Got it. Byron, are you using AI, machine learning? How important is it to your journey? What's going on there?
Yeah, we are introducing in AI technology, and we are in the new generation of a smart network interface card that we use in the meters in order to communicate. We are creating edge computing. We are in order to create new software, new models, machine learning. The reason why is because the meter will be in the future not only for energy commercialization, but also the meter will be a new smart grid device. And it is very interesting. We are, for example, now we are developing distributed intelligence. We have an application that we are very close to have. It is the possibility to create, or we can do energy balance in real time. Yeah, this is very important feature that we are creating now. And after that, we are looking for patterns in the grid. For example, to monitor the transformers. It is very important for the operation of the grid, but also to detect what kind of load is in the grid, harmonics, and not only in the grid, but also behind the meter is very important to have information, because with the EV chargers, batteries, inverters, and all kind of technology will be in the future generating electrical noise. And it is very important to have a new technology in the meters. This is the thing that we are working, distributed intelligence, AI in the devices too, yeah, and the cloud, of course, is very important things for consumers, for customer service, yeah, and in our case, as vendor, from our perspective, it's very important to provide analytic data, but also artificial intelligence in order to do a forecast, for example, yeah, and predict problems or consumer behavior also. Yeah, this is it.
Right. So before I go to Semih, I remember, you know, my first things when I got to Austin Energy in 2003. You know, I graduated as an engineer in robotics and control systems, and I went to work for Microsoft and other companies of software. Then I went to do telecom, and then I went to, you know, went to do computers, digital equipment, and all that. So when you think about the smart grid, it's software plus computing plus telecom. And I'm wondering if you could help the audience understand a little bit about your thoughts on this topic about AI and research. But first, we need to graduate these new smart grid engineers. So
Yes.
are we teaching these engineers all this stuff, or are they just learning classical thing, or how are we different or better?
Oh, no, as I said, we are adapting as well. So we have machine learning, high performance computing courses that we offer. And then we are also offering, you know, languages that will support those, and students coming from Texas State and have that background, like machine learning background or AI background, or they do research when they do their senior design projects. They have mostly work on the like adaptive understanding of you know, how the system can change and so on. So yes, we actually have that.
Could you take a moment and explain senior design real quick, how it works for maybe a company that wants to partner or something?
Yes, we have all programs that we have, not just EE, the senior design class, which is a 1 year long. A company can sponsor a group of students with the idea that students can work on that project with the company's sponsorship and on direction. they can produce at the end a product. Our goal is to make sure that our students have hands-on experience and also kind of challenge with the real world problems. So we also work on multidisciplinary. For example, an E group with the mechanical engineering group can actually work together if a project requires a multidisciplinary approach. So we have courses, and we have really good projects from NASA and some other companies like AMD and so on. So we actually have projects that our students successfully created some really nice work. So
Yeah, that's good. And so, any questions in the audience? Anybody? Yeah, go ahead, please.
So it seems to me that so many project initiatives, all of them seem so important, grid resiliency, new data centers coming up. I just wanted to understand, get inside your head a little bit, Rick and Greg. What are the criteria based on which you prioritize? I have only so many hours in the day, so many days in the year. These are the ones we're going to do first, and these will come later.
Okay, I guess I'll try.
I'll answer first. When I was at Austin Energy, big list of things like playing Pictionary, call Victor Carr, put a fold on his head and throw a dart at it, and then he goes and takes that one and he runs with it. I'm just kidding. Pretty close.
Yeah, we don't do that.
We don't do that either.
So it is very challenging, right? You only have so many resources, which includes both the people and the budget, to do this work. And so, we always start with our long range plan, which looks 3 to 5 years out for substations, transmission lines, bigger projects, bigger capital investment type projects. So we go through a process of looking at the regulatory, things that we have to do for compliance purposes, the customer component, service has to be delivered. It's our obligation. And then we look at any other kind of grid modernization improvements that we want to undertake, such as undergrounding overhead lines, right? So something that's very important to us and our constituents. However, a customer's not waiting on it, and we do have some discretion on when we do that work.
Mm-hmm. Great.
Yeah, we for all technologies across the utility, we gather together the executives that are over the areas that are most relevant for that particular section of our technology environment, and have them just talk it out and rank order what they're going to do first, second, third, fourth, fifth, sixth, 29th, 30th, and just work it out like that. We don't make use of a scoring mechanism or something like that. We just have conversations with the relevant executives.
Mm-hmm. A quick follow-up: has reliability, plain vanilla reliability, kind of fallen below resilience now and flexibility? Where does plain old reliability rank?
The challenge is getting, from our perspective, because we have grid resilience is a strategic goal for the organization, one of the 6. Getting broadly accepted measurement metrics right around resilience. What is resilience? We have great reliability metrics that have been in place for decades, but resilience metrics are somewhat more challenging to come by. So we're going through, like I said, I oversee the strategic planning for the organization as well. We're going to be going into in FY24, which is just starting up. We're going to be going through our next strategic planning cycle. And I think that's going to be one of the things we try to do a better job of taking on is what are we actually measuring when we talk about resilience? So I don't know, Rick from GPS side.
So reliability has always been a staple of our portfolio, right there with customer work. Resilience has been a little bit harder to quantify, so we look at it more in terms of our ability to respond, and providing flexibility for our operators to take action. It's becoming a more and more difficult this conversation to distinguish between the two. But certainly reliability is one of the key fundamentals that we look at when we put together our portfolio of projects. And you know, so it's going to stay there. And resilience is just being introduced.
Thank you.
Yeah, go ahead.
My question's for Rick. What are you doing for areas that have high energy needs, and then you have the electrification actually moving in? So as you said before, the EV penetration of like rental vehicles. So Hertz is going, next year they're going to go all electric. And so everybody else is going to follow after that. But Hertz are usually at an airport. The airport is already, you know, kind of power strapped. So you're going to have these extra added resources that are going to need to be met. But then you also have trucking companies that are also going to go, you know, electrified. So how are you guys looking at addressing that issue?
Yeah, that's a very good question. So through the traditional means of looking to install additional capacity in terms of a substation out there, or adding another transformer to an existing substation, we're also undertaking a significant effort in doing voltage conversion. So going to a higher class of distribution voltage so we can get more capacity into the neighborhoods without building additional lines. We're just replacing 13 kV with 34.5 to add, you know, 2.5 times more capacity with the same footprint, effectively.
Got it. Got it. Yes, go ahead, Sasha.
Thank you. Yeah, Sasha. Thank you for speaking today. I heard, at least from most of you, about reliability. A new concept that I heard was reliability as a service. I know, Rick, you mentioned batteries using AMI information to find the fault and potentially using the localized battery to support that. Greg, I think you're the one that mentioned reliability as a service. Can you define that a little bit? That's new to me.
Yeah. So resilience as a service is having on-site generation for customers that are very sensitive to loss of power. So grocery stores, for example, are like the classic example of that. So if you have that on-site generation, then managing that, how does that function from like your distribution management perspective? How does it function from your kind of energy marketing perspective? How does it, who's reaping what financial benefits from it? All that kind of stuff. So that's resilience and service.
So as a service part, does that mean that's Austin Energy running it, or is that a third-party developer?
It varies, and those are some of the issues that are we're trying to figure out right now. Is kind of the different parts and pieces.
Sounds like a very challenging interconnection conversation.
Yes, Andres. It does.
Go ahead.
My question is to the utility side. Lately, I'm finding more papers about inverter-generated electricity is making the grid unstable.
Mm-hmm.
So I have a two-pronged questions. Maybe the first one is to Greg. Are you feeling that problem already? And the next one is maybe Semih and Andres, both of you. What's the academic side of that problem?
Sure.
Yeah, I mean, that's what I was talking about a few weeks back. We had like 2 solid weeks of ERCOT, pretty close to a rotating outage. And it was right when the sun was going down. So like, I wonder what that might be caused by, right? So it's really a challenge is dealing with that drop off of solar generation at in many cases before I think wind is picking up in the evening. So that's a real challenge for us.
My question is inverters reshaping frequency.
Yeah.
Inverter reshaped frequency does not have rotating inertia, doesn't drive the
Correct. Yeah.
Right.
Yeah. Let me Let me elaborate on your answer from the sort of engineering side of what this is all about. So, traditionally the grid was centralized. You heard the explanation from Hope on Samuel Insull, Chicago, Com Edison, in the beginning of the grid, sort of holistically for everybody, 24 hours of generation. So spinning machines, right? You boil water with a fuel, oil, natural gas, coal, biomass. You're boiling water, right? For those of you that never heard of this, and you create vapor, and that vapor is pushed through a turbine, like the turbine from a airplane, but way bigger, right? And that turbine now is spinning to create the electrons on a magnet, right? So that spinning that is going on, clockwise, is creating a force, pushing the electrons and making them travel through the alternate currents lines, miles, right? If there is no spinning machine, the electrons will travel because of induction, but, they won't travel as much. So if you get rid of the machines, which is what's happening by getting rid of coal and natural gas production and any other burning of water to boiling of water to create steam, now we're moving into, renewable energy, meaning you got now, wind turbines, and you got hydro, and then you got, solar, and then algae and other. And so now you're dealing with inverter base, right? So one of the things that we're going to be doing, and this has been going on for a while, is the notion of doing R&D for the creation of virtual inertia, which is something that is needed, right? But in the end, when you think about, alternate current versus DC direct current, I think, and this is my own personal opinion, just me, Andres Carvalho, that Edison was right. That DC is better. And the problem that we had with DC at the time is that we didn't have chips and semiconductors and all these things needed to control DC, because you can throttle DC, AC cannot, right? So DC has all these advantages, but it's expensive and to move, distance, right? So anyway, so those are my 2 cents on that. I don't know if you want to add more to that.
I mean, as you said, that the more like microgrid, some of the components like being DC in the houses, there will be not just AC, or the DC bus lines or DC lines will be actually getting more and more common. But as I said, that currently we are not doing directly research on that, addressing that point, inverted point. But hopefully after, as I said, that when we are getting our PhD program in a couple of years, that will be a great research area to actually work on. So,
anything you guys want to add to the whole thing or conversation?
So that is, one of the things that's complicating how we run the distribution grid, and it's really complicating the role of the distribution operator in the traditional sense, which not to mention that so now you're going to have to deal with more harmonics than you had to deal with before on the system, which have to be mitigated in some form. And you got a tremendous amount or tremendous number of sources that throttle from source to load, when you pair solar with the battery. So it's really going to be complicated, and that's where we look to academia to help provide some of those competencies for our emerging workforce.
Yeah. Anything you want to add? So what I would say is getting rid of inertia. It's a challenge that today, really, with the current technology, it would be impossible to have 100% renewable grid if there was no storage, right? And the current grid in its current form, as we assume the traveling of that energy on a centralized basis, solar, wind, whatever, with the spinning inertia, if that gets removed, that supply is not going to travel where the load is, right? So something needs to be injected there to make it work. So I don't think nobody has the answer to that. This is why physics cannot be ignored on the fact that we need to decarbonize 100%. It may take us another 5-10 years. We're rushing to build a lab and get the PhD programs and all this thing going. Maybe we'll solve it here in the next 3 or 5 years. But that's a real challenge. So any final questions? Anybody else? One final question perhaps before we go to lunch? Yes, one more.
Yeah, thank you. So that made me think, virtual inertia's not here yet. You got synchronous condensers, they're not so much fun because they don't do anything but take care of your frequency. But we do have, I get emails every day from grants.gov about the funding that the government's putting into research. A lot of it's going towards new batteries, technology, particularly the chemicals that go into it. So batteries are going to get there. I guess this is for all four of you. Are you looking at the, IRA, the Inflation Reduction Act, really is an infrastructure funding mechanism? Are you looking at that? Are you getting funding to be able to do research for pilots, et cetera, for these types of questions, the longer term?
So I'll answer first. In the academic side, we're definitely, head over heels on submissions and all kinds of things. And it's really important. It's really fortunate that it's happening. So we're taking advantage of it. We're hiring 100 postdocs. We're adding some 20 faculty. We're adding PhD programs. We're building the 14 labs. We're full throttle on it. Yep, we do. Any you guys are using any? On money.
So we're hoping to hear on the GRIP grants, soon. Which is, in fact, we do have a project where we're going to look at building a microgrid. Should we get this grant with a compensator and 4-hour battery to demonstrate a true microgrid within our territory.
Correct.
Yeah, I mean, we've excuse me, we've been applying and applying to quite a few grant opportunities as they come up. On the cyber side, we looked at a few of the early ones, but they were more, more R&D focused. And in general, we look for commercially available products and purchase them from other folks that have developed them up. So that tends to be our perspective generally, is waiting until commercially developed products are available.
Anything from you? No? Okay. Well, I appreciate you all being here today. We have lunch. We go here into transition to lunch and a break. So you guys can come up and say hi, get your autograph or selfies. We're going to take a selfie here before we go. Thank you very much. Help me thank the panel. Let's do a selfie for you guys.